Alright, we attach our geometry and fallen leaves fly and rotate, but connected leaves still have no any rotation. Let's add it. So let's create a point warp. So we will use noises for it and jump inside. What we will do? So let's template points. Oops. Run. Yeah. So we have our orient attribute on the connected points as well. So we need it rotated somehow. And to rotate matrix, we have a rotate warp. Oops. Rotate. And what we need? We need a matrix, we need angle, and we need axis. Axis, we will use axis perpendicular to the velocity. So let's create a cross product between our normalized velocity vector and some constant vector. It will be watching up. So now we have an axis and can plug it here. Next, we need a matrix. So bind our orient. It's vector 4. Orient. Let's convert it to matrix. Quaternion to matrix 3. Oops. And plug it to our rotate. And let's convert matrix to quaternion back and export it by an export as orient attribute. Float orient. Let's see how it's changed. So yeah, now it's rotating, but it's rotate all our quaternions. So let's change it. Release equals 0. So we need only connected point. Let's rotate now. Now it's rotated only leaves connected to the tree. Great. Let's make angle. We will use the length of our velocity. So it should depend. Oops. It should depend from velocity. So as faster branch moving, as faster it's rotate. Let's fit it. And we will use 0.4 and apply to the angle. And let's see what we have. Great. Now it's rotating, but all points rotate the same angle at the same time. We don't need it. Let's randomize it. And for randomization, we will use noise applied to our rest position. So rest vector. I use a rest because our points moving, so it shouldn't be changed based on the position. Turbulent noise, position, and multiply our angle by this noise. So let's fit our noise, change it to original Berlin, and it's changed from minus 0.5 to 0.5, and we will use minus 0.2, 0.2, and it will be 0.5 and 1. Let's see what we have. Yeah, now let's change a little. We need to increase our frequency, like 7.5 will be okay. Yeah. Now our vectors moving differently. We need to change noise pattern during the time, so plug time to offset. This is change like a wind. Great. Next, we need to duplicate this one. So now our quaternion moving along one axis, and if we see to the leaves, so they are moving only along one axis, but we need to add some jittering to make more random motion for each leaf, and we will use another rotate, and we create a new angle based on new turbulence, and we need to change it 0.3, 0.3, and it will be minus 0.4 to 0.4, so it will rotate in all direction. Okay, and we need to multiply our offset by the length to make it faster. If the speed is faster, let's move it here. Okay, so we need to fit and change it 1 and 2, so it will be our multiply. So if branch moving fast, it's rotating faster. Yeah, now let's visualize our quaternion, and you see the jitter like on the wind. Cool. I think it's pretty much all. Yes, you can play with these numbers, but yeah, let's make a small play blast to see. Okay, let's wait a little. Okay, it's our play blast and all leaves moving, and you can substitute it by the geometry, so it should work really well. Not a squares, but leaves model. Cool. So We finish our procedural tree rigging system volume 3. I hope you enjoyed.